All right, so I'm going to go over the mean value theorem. What it says is that if f is a continuous function on the closed interval ab and it's differentiable on the open interval ab, then there's going to exist a number c in that open interval ab such that the derivative of c will be equal to f of b minus f of a over b minus a. Now what the heck does this even mean? It's actually not that difficult. It's actually pretty intuitive once you see a picture. All this is saying is that the derivative of a point within the interval is going to be you're always going to be able to find when it's equal to the slope of the line that connects the endpoints. So let me just draw a sketch of this because this is gonna make it a lot easier to understand. So let's draw the XY axis. A little crooked, but I'll be okay to do. Let's just I'm gonna draw this function. Draw this normal function, nothing crazy, just like a line like that. That's my function f, all right? And we're going from A to B. So let's say A is over here. Let's make A a negative number. Let's say B is over here. Okay, so we know that the function is going to be continuous on the interval a b, and it's differentiable since it's smooth. So we're good. Now let's see what this is saying. It says the derivative at some point c between a and b is going to be equal to f of a minus f of b over b minus a. Well, let's show what f of b is and what f of a is, and then what b minus a would be. So f of b is just going to be the value of the function at b. Let's say around over here. So let's call that point. That point would be b f of b. Remember, f of b is just the y value evaluated at b. F of a will be this point over here. That'll be backwards over here, a f of a, and that's b f of b. Now, if we're saying the derivative of c for some point, between a and b is going to be equal to f of b minus f of a over b minus a. Well, let's think about what f of b minus f of a over b minus a even is. And you think about this, like what's slope? What does slope even mean? Slope. Remember back in the day what slope was? That rise over the run. Yeah, we had, or if you remember when you were trying to figure out, the slope when you're given 2 points on your, 2 coordinates of 2 points, you would do something like y2 minus y1 over x2 minus x1. Remember? And what do you know? Just think of this as like, think of A as like your x1 and think of, f of A as your like y1. And think of B as your x2 and think of f of b as your y2. So all you're really doing here is calculating the slope between this point and this point. So what you're doing is geometrically you're making you're basically connecting them. You're making this line. What you're gonna get is the slope of this tangent line here. This is the slope from here to here. That's what this is doing. So what is this saying then? F prime of c is equal to this. So this is gonna be what the slope from A to B. Well, what this is saying is that we can find a point on this function that's gonna have the same slope as this. And you can just basically see kind of geometrically, they would probably be somewhere like over here. If you drew a point over here, remember the slope of a curved line is the tangent line. So I would draw, my slope about over there. And this point, I would, it'd be on the function, it would say it's c f of c, right? And the slope of this line, this purple line, is parallel to this other purple line. They both have the same slope. And you see that C is between A and B. And the derivative again, this is just the way you write it. The slope of the purple line is just the derivative of the function evaluated at C. Remember, this is just this line right here has has a slope, slope equal to f prime of C. So what the mean value theorem is just saying is that you're going to be able to find a parallel tangent line within that interval. You connect the endpoints with the tangent line, whatever the slope is, you're going to be able to find another point within that interval that's going to have the same slope, but be parallel. So let me just do another, just like kind of what just geometric example to kind of show you what I mean. Because this is, again, I'm going to draw a random graph. So make this be a lot, it will make a lot more sense. If let me just do something that's not like so like plain. That's what if I did something like this? What if I went like up, then down, then up again, and down. So, this whole craziness. I'm gonna say that A is over here. I'm gonna say my B is like over here, right? So then I have my B, f of B over there. And I have my A, f of A over here. What about this? So what's going on here, right? What does the mean value theorem saying here? Well, again, we care only about those points. We don't care, whether or not our line's going to intersect the function. So my line would be something like this. Oh, a little crooked, but it's all good. So you see this line. This is the line that I get from this equation. It's just a slope between these points. And it's saying that you could find several, in this case, you guys find several points that will have the same slope where the tangent line again will be the same as this, be parallel. Because and you can pretty much see it's probably going to be at those peaks. What would make sense? Look for where would well, we actually just found it right here, like it coincidentally intersects right here. A tangent line there would probably be that same slope. A tangent line up here, probably over here at the peak, at the local max. You probably have another tangent line with the same slope. And I would even say over here you would probably have, so that you can have more than one. You have several. Down here even. Down here you can even go down, you can go down low. You actually got 1, 2, 3, looks like it's almost 4. And see, like at all those points, remember my boundaries are I want to say, from here, I'm saying from this is my A. A is stopping that. This is my B stopping over here. But look, all of these points have X values, let's I'm gonna call them C1, have another X value here, C2, C3, over here, C4. See, all those points are between A and B. And again, I just drew some crazy line. I didn't like plan a specific line out. I just drew one randomly and just showed you that it's gonna work. So that's what all the mean value theorem is saying. So I'd really advise you to draw it when you're practicing it and learning it, because the mean value theorem is actually a big deal on the AP exam. You can expect for sure to have it on the exam, and most likely they're gonna have like a free response problem dealing with it, because the mean value theorem is actually a big theorem, big deal in calculus. It's probably, some people say it's even the most important theorem in all of calculus. It helps you connect with the fundamental theorem of calculus, which will come later. But anyways, let's do a practice problem so we can know how to handle this on like a test problem or something. All right, so here we got to find finding the tangent line for the function f of x is equal to 5 minus 4 over x. Find all values of c in the open interval 1, 4 such that the derivative of c is equal to f of 4 minus f of 1 over 4 minus 1. So what is it saying? Well, it wants you to find the value of c that will give you the same derivative or slope value here. So let's first find, this is going to actually give me a number. So let's find what this number is. F of 4, you plug 4 into here, remember? It used to be 5 minus 4 over 4, which is just 1, minus f of 1, which would be 5 minus 4 over 1, which is just 4, all over 4 minus 1, which is just 3. And this will just be 3 over 3. Is going to be 1, as we know. Okay, so it wants me to find the value of c between 1 and 4 that will give me a slope of 1, or that when I evaluate the derivative function, I'm going to get 1. So in other words, I want to find where is f prime of c equal to 1. I have to solve for c. I'm trying to find my c value. So let's first find our derivative value. So let's rewrite, this is the same as, let's rewrite f of x as 5 minus 4 to the x minus 1 for that way. So let's take the derivative of this. F prime of x is equal to 0, negative, negative, so 4, x to the negative 2. Here's my derivative equation, interesting equation. So I have to solve this equation for 1. All I'm doing is setting this equation equal to 1. I'm going to set f prime of x equal to 1. F prime of x equal to 1. So I'm setting just 1 equal to 4x to the negative 2. 4 times x to the negative 2, I should say. And I just, using, remember, this is the same as 4 over x squared. Just showing me all the work. 1 equals 4 over x squared. Multiply both sides by x squared, divide by 1. It kind of takes care of itself. X squared equals 4. So my x values could be, negative 2 and positive 2. So both these will give me a derivative value of 1. However, we care about the one that's between 0 and 4. Yeah, it says right there, has to be between 0 and 4. So we don't care about that. This is going to be our answer. Our answer is going to be c equals 2 or x equals 2. Same thing. Don't let this xc confuse you. It's just that c is going to represent this specific x value in the context of these types of problems. So the answer is just 2. And there you go. So yeah, that's all there is to it. But now as a bonus, I'm going to draw you, and go through like the visual, because that, again, this stuff becomes much easier when you do a picture. Sometimes some students like to do it like extra work, blah, 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 I don't have to do it. But like if you want to understand this and make sense of it, definitely do it. So let's draw this function here. Don't expect you to, be a master of this, but let's at least f of 1 will be, it's going to be 1. We know f of 4 is 4, so we know it's going to go through 1, 1. And then 4, 4. Now this function actually looks something like this. It looks something like a weird curved line. Making it really thick, but probably not necessary. But here's our function. That's what the function is going to be. I'm not sure why I even made it so thick, but okay. So what's going on here? What did we do? Well, remember, these are our A and our B. These are our boundaries. A, that's our A, which is like our B. So we want to find the value of C between A and B that will give you the same slope as the tangent line, or the line that would have if you connected those. So if you connected these points, well, we found the slope of this line is 1. We found the slope is 1. That's what was going on here. slope equals slope of that line equals 1. This line goes through that point and this point. And we're like, well, where would the other point be that would make the tangent line just be parallel to this, having the same slope? And we found that it would be right in the middle at 2. We're not right in the middle, but like more on this side, I guess. So basically, again, we were looking for that x value, or that c value, you could say. So we found c to be 2 right here. So it would go through the point 2, 5 minus 4, 2, 3. So that's what we found. We found the point on this curve where you would get a tangent line with a slope of 1, which is the same slope that the tangent line would have going through the endpoints of a f of a and b f of b. And so there you go.